Hello dear students, in this part of the topic we'll see about next concept which are related to the lens. We already learned about different concepts related to this lens. Those are types of lenses and the images which is formed by convex and concave lens. So in this topic, next part is about the uses of concave and convex lens and detailed study about human eye and its working. So we'll first study about the construction of human eye and its working. In this diagram we will see the different parts of the human eye. Out of them, these are the major parts, that is, this is the eye lens, then this is the iris, these are the this is the iris, and between them there is a pupil, a membrane, that is cornea, and here a screen like a retina. And for maintaining the size of this eye lens, these are the ciliary muscles. So these are the some major part of the human eye, and here optic nerves which have to conduct the message towards the brain. How the human eye work, we have to see in this next part. There is a very thin transparent cover, that is membrane, on the human eye, that is called as cornea. Light enters the eye through it. Maximum amount of incident ray is refracted inside the eye at the outer surface of the cornea. There is a dark fleshy screen behind the cornea. This is called as iris. The color of the iris is different for different people. There is a small hole of changing the diameter at the center of the iris, which is called the pupil. The pupil controls the amount of light entering the eye. If the light falling on the eye is too bright, pupil contracts, while if the light is dim, it widens. On the surface of the iris, there is a bulb of transparent layers. This is a double convex transparent crystalline lens just behind the pupil. The lens provides small adjustment of the focal length to focus the image. This lens creates a real and inverted image of an object on the screen inside the eye. So we'll see once again, this is the membrane, is known as cornea, and behind that a fleshy muscle like iris, and in that iris a hole, small hole, that is pupil, and behind that here a lens. So these are the parts which we already now described. Screen is the screen is made up of light sensitive cells and is called a retina. A screen on which the images are formed by the eye, that screen is known as retina, and this This screen is made up of light sensitive cells. These cells gets excited when light falls on them and generate electrical signals, and these signals are conveyed to the brain through the optic nerve. Later the brain analyzes these signals and converts them in such a way that we perceive the object as they actually are. So like this the human eye works. While seeing objects at large, infinite distances, the lens of the eye becomes flat and its focal length increases. While seeing nearby object, the lens becomes more rounded and its focal length decreases. This way, we can see objects clearly irrespective of their distance. So, the capacity of the lens to change its focal length as per need is called its power of accommodation. What is power of accommodation of the eye? The capacity of the lens to change its focal length as per need, it is called as its power of accommodation. Although the elastic lens can change its focal length to increase or decrease it, it cannot do so beyond a limit. So you will get idea about that capacity of the lens to change its focal length. If you see the size of this lens, that is lens becomes here flat, and here for nearby object the lens becomes rounded, and for objects which are far away the lens becomes flat. The minimum distance of an object from a normal eye at which it is clearly visible without stress on the eye is called the minimum distance of distinct vision. What is minimum distance of distinct vision? The distance, the minimum distance of an object from a normal eye at which it is clearly visible without stress on the eye. That is known as minimum distance on distinct vision. The position of the object at the distance is called the near point. For a normal eye, near point is at 25 centimeter. The farthest distance of an object from a human eye at which it is clearly visible without stress on the eye is called farthest distance of distinct vision. The position of an object at this distance is called the far point of the eye. For the normal eye, the far point is at infinity. The eyeball is approximately spherical and has a diameter of about 2.4 centimeter. The working of the lens in human eye is extremely important. The lens can change its focal length to adjust and see objects at different distances. In a relaxed state, the focal length of healthy eye is 2 centimeter. The other focus of the eye is on the retina. Defect of vision and their corrections. Some people cannot see things clearly due to loss of accommodation power of their lenses in their eyes. Because of defective refraction by the lenses, their vision becomes faint and fuzzy. In general, there are three types of refraction effects. One is nearsightedness, that is myopia, then farsightedness, that is also known as hypermetropia, and presbyopia. What is nearsightedness or myopia? In this case, the eye can see nearby object clearly, but the distant object appears indistinct. This means that the far point of the eye is not at infinity, but shift closer to the eye. In nearsightedness, the images of distinct object forms in front of the retina. There are two reasons for this effect. One is the curvature of the cornea and the eye lens increases. The muscles near the lens cannot relax so that the converging power of the lens remains large. Then, second reason for nearsightedness, the eyeball elongates so that the distance between the lens and the retina increases. This defect can be corrected by using spectacles with concave lens of proper focal length. This lens diverges the incident rays, and these diverged rays can be converted by the lens in the eye to form the image on the retina. The focal length of concave lens is negative, so a lens with negative power is required for correcting nearsightedness. The power of the lens is different for different eyes depending on the magnitude of their nearsightedness. In short, we are using divergent lens for this purpose. Divergent lens means concave lens. The spectacle of concave lens we should use to recover this defect. Then farsightedness or hypermetropia. In this defect, the human eye can see distant objects clearly but cannot see nearby object distinctly. In this defect, the human eye can see the distant object clearly but cannot see nearby object distinctly. This means that the near point of the eye is no longer at 25 centimeter but shifts further away as shown in your textbook diagram. The images of nearby objects get formed behind the retina. There are two reasons for farsightedness. That is, first, a curvature of the cornea and the eye lens decreases so that the converging power of the lens becomes less. Second reason, due to the flattening of the eyeball, the distance between the lens and retina decreases. This defect can be corrected by using a convex lens with proper focal length. This lens converges the incident rays before they reach the lens. The lens then converges them to form the image on the retina. So for correcting this defect, we have to use a converging lens, that is convex lens. The focal length of convex lens is positive, thus the spectacles used to correct farsightedness has positive power. The power of these lenses is different depending on the extent of farsightedness. Then we'll see about presbyopia. Generally, the focusing power of the eye lens decreases with age. The muscle near the lens lose their ability to change the focal length of the lens. The near point of the lens shifts further from the eye. Because of this, old people cannot see nearby objects clearly. Sometimes people suffer from nearsightedness as well as farsightedness. In such a case, biofocal lenses are required to correct the defects. In such lenses, the upper part is concave lens and corrects nearsightedness, while the lower part is convex lens which corrects the farsightedness. Then uses of concave lens for medical equipment, scanner, CD player. The instruments use laser light. For proper working of the equipment, concave lens are used. The peep hole in door. This is a small safety device which helps us see a large area outside the door. This uses one or more concave lens. The spectacles, the concave lenses are used in spectacles to correct the nearsightedness. In torch, we are using concave lens to spread widely a light. In camera, telescope and microscope, we are using the concave lens. The use of convex lens. In sample microscope, we are using convex lens for getting a 20 times larger image of an object. Here you will see the diagram of simple microscope. In compound microscope, there are two convex lenses used for magnification of the image of the object. And in telescope, we are using two lenses, convex lenses, for observing the objects which are so longer. This telescope is used to see a distant object clearly in their magnified form. Telescopes are of two types, that is refracting telescope and reflecting telescope. In reflecting telescope, the mirrors are used and also lenses, and in refracting telescope only the lenses are used. In both of these, the images formed by the object act as a object for the eyepiece, which forms a final image. Objective lens has large diameter and larger focal length, because of which maximum amount of light coming from distant object can be collected. So these are the two lenses used in refracting telescope. This is the objective lens and this is eyepiece. In optical instrument, the convex lenses are used. That is in camera, projector, spectrograph. the convex lens are used. And in spectacles, the convex lenses are used for recovering the defects, that is farsightedness. So these are the different uses of convex and concave lens. Then what is persistence of vision? We see an object because the eye lens creates its image on the retina. The image is on the retina as long as the object is in front of us. The image disappears as soon as the object is taken away. However, this is not instantaneous and the image remains imprinted on our retina for 1/16th of the second after the object is removed. The sensation of retina persists for a while. This is called the persistence of vision. The retina in our eyes is made up of many light sensitive cells. These cells are shaped like a rod and like a cone. Rod like and cone like. These are the two types of cells which are light sensitive in the retina. The rod like cells respond to the intensity of light and gives information about the brightness and dimness of the object to the brain, while conical cells respond to the color and gives information about the color of the object to the brain. Brain processes all the information received and we see the actual image of the object. Rod-like cells respond to faint light also, but conical cells do not. Thus, we perceive colors only in bright light. The conical cells can respond differently to red, green and blue colors. When red colors falls on the eyes, the cells responding to red light get excited more than those responding to other colors and we get the sensation of red color. Some people lack of conical cells responding to certain colors. These persons cannot recognize those colors or cannot distinguish between different colors. These persons are said to be color blind. Apart from not being able to distinguish between different colors, their eyesight is normal. Means in case of color blind, the eyesight of this person is normal, but they are not able to distinguish the different colors. So dear students, we already learned about different concepts related to the eye and lenses. Also we studied about different uses of convex and concave lens in this part of this topic. Here this lesson is complete, but if you have any doubt, you have to ask me on this phone number or you have to write your questions on WhatsApp. Before that, we have to read the lesson which is in textbook and we have to solve the exercise. Thank you.